that's my thing. I always do review. So can we do a short review? Does anybody have questions? Yeah?
Could we go over the difference between maybe a pair and like mapping?
Okay. Right. So the question was, can we go over the difference between a pair and mapping? They're actually apples and oranges. To compare pair and map, it would be to say that a map contains pairs. And to make a generic pair, you would use make pair. And you would specify type 1 and type 2, and then give instances of variables or objects of type 1 for the first spot and type 2 for the second spot. After a pair is made, the pair offers data members of, so if this is the pair, there's dot first, which will give you the value of that, and there's dot second, which will give you the value of that. Now, where you'll see pairs is in the return of something like find on a map. Find will return an iterator. The iterator is a pair, and that's why you can get at the map's key from first and the map's value from second. Okay, does that help?
Yeah, so in the maps, it's just a container of pairs.
Yes, a container of pairs. That's a good way of putting it. Other questions? Okay, I want to do two things today. One is cover debugging to a good degree, actually. And the other is to tell you about your homework assignment over break. It's chapter 10.1, so one chapter out of zyBooks. Okay? So do that during break. It'll be due Monday night when you return. So chapter 10.1, if I remember right. Okay, now chapter 10.1 has to do with polymorphism. Ooh. So we are getting back to the course material that I'd hoped we would do. We've taken a short excursion into containers. We started with pointers. That is intended for this course. And we took a short excursion into containers. And now we're coming back to material that was intended for this course. Interestingly, polymorphism is a subject of a course which is known as object-oriented programming. That course is going away because the material is going to be brought into 1820. Okay, so let me see if I remember my password. Oh, I did. Good. All right. So far, when we've looked at classes and structs, the only expressive ability that we've had is you can think of as has-a. Okay, let me spell that. And you should be totally comfortable with this spelling because everything in your generation is misspelled anyway. Like the name of this product here is a swivel, S-W-I-V-L. Okay. So if it doesn't have a cool spelling, then it's just not hip and modern. But let's say we spell it like this. It has a. So the classes and structs that you've been working on, let's take frequency in node. So you can say that node, all nodes, has a frequency. right? So when we start talking about polymorphism, we introduce a new misspelled word, ISA. So an example of ISA is, suppose we had a class dog. Well, a dog is a mammal. Yes?
Okay. I've never ever seen that in my entire life.
You've never seen this?
Yes.
Oh.
Definitely talked about inheritance and polymorphism and stuff. Where does this come from? I'm so confused.
Okay, so your question is that you've looked at polymorphism before and inheritance before, but you've never seen these terms.
Yes.
Well, obviously, it's everything that you've looked at before is terrible, and I'm better. Yeah.
That makes sense.
Okay. Well, different instructors have different ways of trying to provide an image of a way of remembering. So I find this one useful. I heard it from somebody else. You can find it in the literature, perhaps more properly spelled. So I think it's a good way of remembering that a class or a struct has data members, so the class has those.
I'll get the purpose. I just never seen that.
Okay. Well, it gives me great joy to have presented something you haven't seen before. So, good. All right. The other idea is something is so a dog is a mammal, even if that's not wonderful grammar. I suppose it's so acceptable. So C++ is an example of an object-oriented programming language. So did you find ISA on the web? Or?
No.
Yeah. Okay. We should Google it and see what comes up.
You want me to Google it?
Yeah, go ahead. I hope it's not naughty.
ISA or HASA?
Either one.
All right.
Okay, say C++ ISA or C++ HASA.
All right.
Yeah, like I said, Okay, and if it's not on Google?
It looks like it's something in Chinese. A bunch of Chinese things.
Okay. Well, obviously I've had a global footprint. Yeah. Okay, so the C++ is an example of an object-oriented programming language, and the notion of object orientation is a way of adding expressive power to your programming. How can you express relationships between data types or objects embodying data types? So there's a very natural way of doing that in C++. It is the subject that we're going to study next. So chapter 10.1 is an introduction to it. It might actually even have more detail than what I'm prepared to go into right now. What I'm going to do right now is simply to present a taste. So we're not really going to study it right now. I want you to see it so that 10.1 makes more sense and you're psychologically and emotionally prepared to study it when you come back from break. Okay? And then we'll go into this other thing that I want to talk about, debugging. All right, so on screen, there's a class named mammal. And mammal has a method called speak, which returns the noise that mammals make as a string. And if I were to declare a mammal, I could say, let's call it M. I could say m.speak, and that would return a string. Okay. Now I'm expressing the relationship between dogs and mammals. Perhaps I could have made an intermediate canid, but I'm not a biologist. Don't even play one on TV. So the idea is class dog : public mammal. So the public is here to say what's public in mammal should stay public. Okay? And the dog is derived from mammal. So we can say that dog is a mammal. Right? Now, this here is a specialization. You notice it says string speak. Well, the way that you can wrap your minds around both classes having a speak is that dogs speak in a different way or more specialized way than a generic mammal. So they both have a way of speaking. Okay? So let's try and see if we can make a mammal speak and a dog speak. So the string returned by mammal speak is generic mammal sound because I don't know what kind of mammal it is. There are other ways of handling this, but this is the way we'll handle it today. And a dog, if asked to speak, a dog object, you say speak, it'll say woof. Okay? Now here's something interesting. Here's a vector of mammal pointers. Okay? The vector is called V. Now, interestingly, I can add a mammal to the vector of mammal pointers. I can also add a dog, even though it's a different class. I can do that because all dog objects derive from mammal objects. Okay? All right, so I've done that. V at 0 is going to be a mammal, and V at 1 is going to be a dog. So I'm going to ask each one to speak. Let's see what we get. That was the wrong window. Okay. Oops. That's not what I expected, or perhaps not what I intended. I did expect this. So both dogs and mammals made the same sound. So even though dog has its own version of speak, it's still called what's called the base class version of speak. And you can understand that because the way I'm getting to the dog is through a vector of mammals. So the way I've written it so far, when I call a pointer to something that derives from mammal, I get the results from mammal. So here comes this polymorphic behavior. And poly means many, and morphic is like shape. So many shapes. I'm going to add a keyword that you've not seen before to the mammal. I'm going to say the keyword virtual. Okay? And I won't go into details at all today. I've just added this keyword. Let me recompile. And now run it again. And asking a dog to speak produces woof. Yes?
So that is saying virtual, basically just like overriding that function with something else, or is that different?
It's overriding in a way, but you can think of overriding as in two ways. One might be to hide the other one, to replace it, and the other, so you can't get at it at all. But the word virtual here is causing the compiler to examine what the thing really is, in this case a dog, versus what I stated, which is a mammal. It's on a vector of mammal, but it is a dog. And it is, well, dog is a mammal. I've added the dog to the mammal vector. So the virtual keyword says, literally it says, don't do what I said, do what I meant. Okay? So that is all we're going to look at today. Chapter 10.1 will give you some more background. One more thing that I do want to talk about is the way that I'm deleting from the vector, because I don't want that memory leak, remember? I don't want Valgrind, if we were to run it, to complain to me. And the way that I'm going about it, well, first of all, let me ask you the question. Why do I need to remove, if a vector, when it goes out of scope, will just remove itself, why do I need to be concerned about this? See if it's let everybody else suffer. 1, 2, anybody? Anybody? Okay, they've suffered enough. Let's see. Okay, Sam?
Because you're dynamically allocating the classes mammal and dog within the vector.
Exactly. That is exactly right. If it were a primitive type like an int, well, I know how to make an int go away. But since the vector contains pointers, the built-in destructor has no idea how to eliminate these pointers, the results of the dynamic allocation. So Sam is exactly right. Now, the way that I'm doing it is, while the vector still has something in it, delete something in it. So ultimately, it'll run out of things and the loop will stop. That's the idea. But a couple of things to point out is, one, why am I using end instead of begin? I believe we talked about, yeah, go ahead, Sophia.
If you delete from the beginning, then it has to shift everything back, so it's just easier to delete.
Exactly right. So what Sophia said is that the way that a vector is implemented, if you were to delete from the head, from the beginning, it would cause overhead of shifting all the later values down towards the beginning. However, if you delete from a vector, erase from a vector, we'll talk about the difference, delete and erase. If we do it from the end and we remove things from the vector, there's no overhead in shifting things around. Okay? So what is the, if I can, let's move on to the difference between the delete and the erase. Why do you think I need both? Okay, in the spirit of what I was talking about before, let's give other folks some time to feel awkward. Go ahead.
In the while loop, you're passing in not like the initial vector, you're passing in like a copy of it, and then you're accessing the reference to it in the while loop.
Well, I'm not sure I could go with that. So the comment that was made that we're working on a copy of some kind, that's not correct. We are working on the original V. Now, where you get copies, potentially, is when you pass something as a parameter. If you pass it as a reference, a copy is not made. If you just simply pass it, a copy is made. Okay. Want to try again? Go ahead.
I'm not total setting on this, but I think when you delete the new mammal instances, you're deleting the class, but the pointers might still be there that are actually in the array.
That's it. The delete follows the pointer and deallocates the memory that was allocated. Only the pointer is being stored in the vector. It's up to the erase to actually remove the cup that was holding the pointer. A comment?
Would not the vector deallocated by itself from the pointer array?
Yes, it would, but look at how I've coded it. The way that I've coded this, which is not the only way to code it, if I didn't do the erase, then the length of the vector would never go down, and the loop wouldn't terminate.
Oh, I see.
Yeah? Okay, so each time erase from the end is called, the vector is going to reduce its length by 1. One final thing, why is it .end -1? Andrew?
Because .end is the space after the last item in the vector, so you have to do -1 for that.
Yes, exactly right. So .end is an iterator that gets you to one item past the end of the vector. And anytime you have a container that has .end, the same statement is true. It's one past the last thing in the container. Okay? Okay. That was fun. Question?
Yeah, I have a quick question about when you're creating the classes. Other programming languages, you can do an override. So like when you make the dog class, you can override the speak method of like the superclass.
Mm-hmm.
C++ have that similar, or is that basically what you use in virtual for?
That's what I'm using the virtual for. Right. Okay. And I'm getting the choice, by the way. I could either get the functionality of the base class or of what's called a subclass. So a dog is a subset of mammals. So it's a subclass of mammals. Anybody else? Okay. I do not present from PowerPoint much, but this is I just put this on the Facebook machine so that you can have a copy of this. In my own modest, I'm always modest. It's one of my best features. Not that I'm bragging about being modest, but I think I'm kind of world famous for this talk. It has changed people's lives, and that's actually a true statement. So here's the summary, the takeaway message. I'm sorry, I don't have time, or actually this is a 100-minute course. I might have time to do the full talk. But the idea is pay attention to this because it can change your life. It can add to the quality of your life, right? You can go out dancing instead of slamming Red Bulls. Okay? Don't be like Fredo. So the idea behind this talk is to counter the claim that debugging can't be taught. It's an art form, right? Either you get it or you don't. I say, let me look right at the camera. I say that's bullshit. Okay. All right, there. So debugging is an example of science. In fact, it's based on the scientific method, is my claim, and science can be taught. So the idea that debugging can't be taught is BS. So you just need to be, perhaps you need to just be shown. Okay, so this is probably how many beginning computer science students debug. Program doesn't work, make a change. Does it work? If it doesn't work, make a change. If it doesn't work, make a change. If it doesn't work, make a change. Okay, so this is you. In fact, maybe it's worse than you because each time you make a change blindly, you might be damaging your hamster wheel further and further. So, no, this is not an ideal algorithm for debugging. Instead, you can put debugging on a rigorous level by using this version of the scientific method. The first thing you've got to do is, I lost my little pointer thing, oh, it's a screw. I can just screw it back in. Okay, so somehow I managed to unscrew it. Doesn't seem to want to screw back in. All right, I'm afraid if I use this on the monitor, I might scratch it, so I'll be careful. All right, so first, take a moment. Something went wrong. Take a moment and think. Observe. Gather in all the information that the bug is giving you, because almost always the bug, well, I'll say always the bug is giving you more information than you might think. The next important step is what would explain the behavior that you're seeing. You have to formulate a hypothesis. Without that, you're just changing things blindly. Okay? And then finally, you need to test the hypothesis. You need to devise a test specifically to test the hypothesis. Otherwise, there was no point in having the hypothesis if you're testing something else. Okay? Question? No? Okay. So debugging really is methodical if you're doing it right. It's not just swag. Do you know the definition of swag in this case? Anybody? A scientific wild-ass guess. All right? So that's not what debugging's about. Debugging's about methodology. All right, so a way that I would spin that is a fix isn't a fix until you know why it's a fix. Okay, just because you made a change, look at that. By not looking at it, I was able to screw it in. So just because, that's actually a Heisenbug. We'll talk about that. Just because you made a change and the program, the unwanted feature, let's call a bug an unwanted feature. Just because the unwanted feature went away doesn't mean you fixed it. It may more likely mean you covered it up. Okay? And it's not fixed. So unless you totally understand why what you did caused the problem to stop, then you haven't caused the problem to stop. Okay? All right, so another point is you formulated a hypothesis, you did a test, and it didn't help. Remove your test. Okay, remove the changes that you made. Now, I do have a footnote there. It says, unless you're totally certain that you are actually fixing a different bug. Because it does happen quite a bit where you're hunting for one, and then you're looking at your code in a critical manner, and you look at your code and you say, wow, how would this ever have worked? because of that, this other thing. Okay? And even if you do fix this other thing, then you have to understand why it's a fix. And you should still test it critically to ensure that it was a fix. Okay? If you don't do this, then you're chasing a moving target. You're the hamster on the hamster wheel if you don't remove what you just put in. Okay? Okay. This is a crash. If you're looking for the bug, it's way back there. At some moment, the locomotive began to leave the tracks. That's where the bug is, not here. This is the crash. Right? So, when a program crashes, you are seeing the results of a bug, not the bug itself. And as you track it backwards, you'll probably realize that you're seeing the culmination of a series of unfortunate events, not just one. So where there's one, there probably are many. And this is one of my high school teachers, Mickey Cohen. He was a marine biologist. He's an old guy now. He is a marine biologist, and he was talking about surf clams on a beach. So where there's one, there's probably a lot of them, and it's the same as computer bugs. Okay, so bugs want to be found. They announce themselves in some often pretty articulate ways. But that goes back to this first point. Observe, gather data. If you don't do that, then you're ignoring how the bug is announcing itself. Why would you do that? Why would you do that? Give me another Red Bull. Sorry, I can't go dancing. Okay? Another rule that I call Conan Doyle's law: when you've eliminated the impossible, whatever remains, however improbable, must be the truth. That's from The Sign of Four in 1890. If you haven't read Sherlock Holmes, I suggest it. It's a lot of fun. Okay? This is Basil Rathbone, the definitive Sherlock Holmes, not this crap that they've been producing recently. Ugh. All right, so what does this mean? How often have you said the bug can't be there? Okay, so if the bug can't be there, and it can't be there, and it can't be there, and it can't be there, well then you shouldn't have a bug, should you? What this speaks to is that at some point you have to question your assumptions. The bug can't be there, that's an assumption. This value is correct. That's an assumption, unless you've tested it. Then it becomes a fact. Okay, so remember that. Write in small units, test in small units. So repeat after me. Write a little, test a little, write a little, test a little, write a little, test a little. Okay? Come on. Okay, good, good. The point is that you're building a building. If you are unsure of the foundation, there's no point in building the first floor. If you're unsure of the first floor, no point in adding a second floor. Okay? So write a little, test a little. Okay? I write only as much code, the minimum amount of code I can write to get to the next test. I might modify a single line of code and move to the next test it. Okay? All right, so another thing I say, always play defense. And the reason for that, there is this notion of defensive programming. Okay, I didn't invent that, but I'm advocating it. So the extra work of being defensive, writing defensive code, is finite. So debugging time is not necessarily finite. Okay, so that extra work of programming in a defensive manner, well, that little extra work may save you hours or days or weeks of time. Okay, an example of defensive programming, anybody? You've all done it. Didn't I tell you in the specs for the projects, your projects use argv sub 1? I told you, and I hope you did, to check the arg count, argc, to make sure that argv sub 1 exists. That's an example of defensive programming. You guarded yourself against the possibility of dereferencing a null pointer leading to a crash. That's an example, so you've already done it. Okay, so that part of the talk is where I present these sayings. Now this part of the talk is examples of putting these sayings into practice. Every one of these situations has occurred. Okay, what time does class start? End?
1:25.
Oh, good, good. Yeah, so an hour from now. So every one of these situations has occurred. In fact, what you see there is the inspiration of this talk. Okay? All right. My code crashed. I added a printout, and now it doesn't crash. I fixed it, right? No. Do you understand why it would be a fix? No. Did you actually fix it? No. Is the bug still there? Yes. This is an example of something that can often happen when you're dealing with pointers. So now you know how to use pointers. So now you are a potential victim of this. This is known as a Heisenbug. I mentioned it a few minutes ago. Does anybody know where the term might come from? Go ahead. The Heisenberg uncertainty principle. Werner Heisenberg said that there are situations in which looking at the situation changes the situation. He's talking about like subatomic particles. So what it means here, look at it. I put in a printout because I was looking for the bug and now the bug is gone. So in essence, when you're looking for it, it's not there. But when you're not looking for it, it is there. That's a Heisenbug. Anybody read Catch-22? If you haven't read Catch-22, you really, really should. Okay? That book has a character named Major Major. And Major Major is promoted to Major because of a cleric or somebody had a sense of humor, and his last name was Major, so they made him a Major, and now he's Major Major. And he is supposed to be in a position where people can come to him with issues, and he instructs his assistant that people can only see me when I'm not in. Okay? Same thing. Oh, God. Okay. So I have this error. What does the error say? I don't know. I didn't read it. Okay. Maybe a dialog comes up that says error, and you just push OK because you want to get to your debugging. Well, did you read the error message? No. So anything that the error message may have been giving you, any insight it may have been giving you, you ignored, right? So The bug is jumping up and down, saying, here I am, and you say, oh, look at the cat, right? Okay, so don't do that. Okay, don't just click madly, move on to the next thing, right? Take a moment, take a deep breath, take in all the information that's in front of you.
Take a deep breath in through your nose and let your belly push your hand out.
Who's that? Is that me?
I don't know.
Maybe I've never had audio before. Okay. Okay, so make an effort to listen to the bugs. Don't just debug. Okay. My code crashes. Well, look, you've got some warnings. Well, so? They're just warnings. Okay, let me tell you something. Warnings literally have the word warning in them. Okay? So what part of the word warning would you want to ignore? All right? So don't do that. All right? Don't do that. Warnings are significant. Don't ignore them. By the way, if when grading your code has even one warning, you lose 10% of your grade. That's 10 points out of 100. Comes right off if you have a single warning. So I expect not to see one ever. Again, this is an example of the bugs want to be found. This was embarrassing when this happened. Embarrassing for me, and I think it was more embarrassing for me to hear that than it was for the student to say it because they were oblivious. We've talked about memory leaks. A memory leak happens when you are dynamically allocating memory but forgetting to free it. This is a real problem if the dynamic allocation is occurring in a loop. Okay, if during a loop you allocate a gazillion bytes and you free gazillion minus 1, after a while you'll crash. Okay? Now there are tools to help you find memory leaks, for example, Valgrind. There you go. Valgrind will tell you if you have leaks. Okay, that was me during that conversation. All right. Now, by the way, when I teach graphics, I grade the graphics projects, or at least I prefer to grade the graphics projects interactively. So the student will come in, and the first thing I say is, launch your program. And then I will start reading the student's code and asking questions. It's an oral examination. And that code better, maybe that takes 15, 20 minutes. Your program better still be running when it's time to go look at the program, the results, the output. Okay? Now, think about it. You're working on the code for a pacemaker. Here we go with the pacemaker again. It would be really interesting if I ever should need one after all this talk. Wouldn't it be interesting if your memory leak took 4 weeks, 9 weeks, 2 years to cause a crash? And it gets traced back to you and you say, well, it worked for as long as I tested it. My problem. Okay? So if you're in a position to have a program which is expected to run a long time, then you should test it by running a long time. Okay? After a while, my program stops responding. Do you have an infinite loop, maybe? No, I use whiles. Okay, so infinite loops are a thing. You may have experienced one. They are such a big thing. Apple's California headquarters, the address is 1 infinite loop. Okay? So if the program simply stops responding to you, perhaps you look at an activity monitor on the Mac. You see that the CPU utilization is pinned to the top. Well, there's your sign. You have an infinite loop. So where should you start looking? At loops. Okay? Yeah. Yeah, go ahead.
Most IDEs have infinite loop detection. Like, if you type a loop that has no ending check, VS Code or IDEA J or whatever that's called, it will tell you that, hey, this is an infinite loop. You shouldn't, and it won't even run.
Maybe if you're lucky. Okay. I haven't seen that personally, but maybe if you're lucky, it does. Okay, my code works great except when I give it this input. Well, did you try single-stepping that input? No, what's that? So you got to get to know your debugger. And we have not, at this point, spent much time using the debugger. We have to fix that. Okay? And when we do talk about how to use a debugger, I'll share techniques with you to force the bugs to happen. For example, in FrankenMap, the project you're working on now, you have 78,000 words. Let's say your bug only appeared on word 58,536. So clearly you're not going to single step through it. There are techniques that you can employ. Okay? So, hey, if you have questions, you can interrupt me. We have plenty of time. Okay? All right, I looked everywhere. Did you look here? No, it can't possibly be there. Which one is this? That's Conan Doyle's law. When you have eliminated the impossible, whatever remains, however improbable, must be the truth. What this is really talking about is assumptions. At some point, you have to question your assumptions. This is the same conversation. Here is a technique. Let me outline the technique. Okay, so after you have included either assert.h, which is the old version of it, or cassert, which is a C++ style assert, then if you know something to be a fact, or you believe something to be a fact, in other words, one of your assumptions, then you can assert the fact. Like the following way. You would say, assert some Boolean expression. So if I get here, I know the pointer can't be null. So I won't be dereferencing it. That's an example assertion. If I get here, I have a good pointer. Well, if you add this assertion, then when you compile your program in a debugging mode, which is what you have been doing pretty much, actually, you've been doing that as long as you've been using the VM. You've been exclusively in a debugging mode. When you're in a debugging mode, asserts are active. The mode that you're in when you're not in debugging mode is called release mode. The difference between them is in debugging mode, the compiler inserts more safety checks. including activating the asserts. When you're in release mode, this doesn't even show up in your, it takes no time and no space because it gets removed. Okay? Okay, you remember I talked about the locomotive? At some time in the past, the bug occurred. At some point in the past, the locomotive began to leave the tracks. Okay? So an assert can stop the locomotive right at the instant that the wheels started leaving the tracks. Okay? Because when you're running in debug mode, a debug build, the assert is always there, always watching. Anytime this Boolean expression becomes false, your program crashes. If you're running inside a debugger, then it traps right to the debugger on this line. And you say, oh, this Boolean expression is supposed to always be true. In this case, it's false. Let me figure out why. Okay? Okay, yeah. Maybe you haven't experienced writing 5,000 lines in a day. I have. Students later in their careers have. Sometimes I find myself writing code like food poisoning. That stuff just has to come out. And you know what? It's not a terribly effective mode to be in, because where are you going to find the bug? Didn't I say write a little, test a little? Okay, you wrote 5,000 lines and then you tested it and it doesn't work. Where are you going to find the bug? Okay? Where is it? It's somewhere in 5,000 lines of code. So write in small units, test in small units. Write a little, test a little. This will save your bacon more times than you think. Write a little, test a little. Always be sure of your foundation before you build the next story. Okay. Okay. Now, we have not talked about commenting, and I have not deducted, actually I haven't graded any of your projects yet, so clearly I have not deducted any points for lack of commenting or poor quality commenting. But I would if you did that, right? Well, anyone who knows the language can tell that you said I++. I know what that means. I can read the bloody code, right? So this is useless as a comment. Absolutely useless. You do this and I'll take points off. Duh. Okay, so comment your thinking, not your code. Okay, yeah.
Can you put like reminders in there? Because sometimes like when I want to go back and look at stuff, I'll put like code like check this Kyle or like, you know.
Would you characterize that as a to-do?
Kind of, yeah.
Okay, yeah, so a to-do is perfectly fine.
Because it's like my process. I like, you know, I go back and go through it.
Okay.
So can I keep that in there or no?
Well, if you're handing it in, one would presume that you did go back and check it, right?
Did you do you like to see our process of how we like worked it? And no, do you not care?
So the question for the video, the question is, do I want to see your process? Do I care? I definitely do care, and I don't want to see your process.
Okay.
So let's refine that. The best opportunity for me to see your process is when you come to my office and we talk it through. I think the very best mentorship that I can give you is in that environment, when it's just you, just me, and your code. Okay? Right. So even if you get a terrific score on your programs, you get 100%, I bet there's an awful lot we could talk about if you come for a visit and we personally, interpersonally, talk through your process, talk through your code. Okay? So I invite you to do that. All right, you know what? Think of the next person who's going to read your code, because it's probably going to be you. Okay? The next person to read your code is probably going to be you. Are you going to remember what something did 6 weeks from now? You say, Professor K, that's ridiculous, because 6 weeks from now we'll be on a different project. Well, tell you what, for some of you, 3 years from now, you'll be at work and your projects won't last a week. You're going to have to come back to that code again and again and again. And you know what? When you're coding well, when you're really coding well, it's a meditation. You are in the zone. There's nothing but you and the algorithms and the data structures. You are at one with your code. It's a meditation, I'm telling you. Now, one of the purposes of commenting is to allow you to get back to that meditative state after somebody knocks on your door and says something like, well, I don't know what you would do in the dorm, but in my house it would be, can you take out the garbage? Okay? And it's like all of the balls that I was keeping in the air and that I was juggling, they all come crashing down. The meditative state is over. If I have no comments, it's going to take a while to get back there. But if you are commenting your thinking, not your code, that's what will allow you to get back into the meditative state faster. And that's where you need to be. Okay? Okay. All right. Next person to read your code, it's probably going to be you. All right. This is interesting. Did you test your code before you wrote it? Duh? Okay? Did you test your code before you wrote it? How can you do that? Maybe it's a good idea to write your comments before you write the code. Think about that. As your problems become more sophisticated, the algorithms and the data structures become more sophisticated. You may find yourself down the rabbit hole only to realize that your code was never going to work because you've made some fundamentally flawed choices about algorithm or data structure. So if you write the code, back up, if you write the comments before you write the code, it's like talking it out with a friend. You get to hear yourself work through your plan. So if you write the comments before you write the code, it's like having somebody listening and pointing out the obvious flaws. And if you didn't do that first, you may find yourself, after dozens, hundreds of hours into writing and debugging, only to come to the conclusion that you should never have been here in the first place. Okay? My code doesn't work. I look over the shoulder and it says, usually it's not as publicly presentable as I need sleep. Usually it's a bunch of curses strung together. And so I say, well, what does the variable I need sleep do? And I said, I don't remember. I needed sleep. I was tired. Okay? So, you know what? Descriptive variable names really, really, really help, even though there's more to type. And besides, your editor, once you start typing in a few letters, it'll offer to complete the long variable name for you, won't it? Okay, sometimes too much. Okay, so the idea is this: typing is finite, debugging isn't guaranteed to be finite. Okay, so long variable names help you, or I should say specifically, descriptive variable names help you get back in the zone faster by helping you understand your code. Now, it's really a shame, it is really a crime that very often an instructor will stand in front of the room, I do it, and I use a variable named I. Right? What the hell does I do? I don't know, what does that describe? It doesn't describe anything. So don't do that. Maybe you could use, if you're using it for a loop counter, you might call it, I don't know, loop counter. Right? If you're using it as an index through an array, what the heck, call it index. So instructors often use I as a variable name. It's traditional, and it might save time and maybe saves effort on your hand, but really it teaches a bad lesson. So when I use I, you should look at me and just shake your head and say, he's losing it, he's too old. Okay? So you don't do that. You're young, you can type. Okay. You may find yourself writing multiple statements on the same line. I don't know, maybe it makes sense to you, but it's not going to make sense to you in 4 weeks. It's not going to make sense to somebody else reading your code. Here's the problem. The bug, the sin, is typically one of these ones in the middle. Because as you're reading the code, looking for the bug, your eye will be drawn to that one or that one. You know, proximal or, I don't know, what's the other word? Proximal or, you're going to be looking at the first one and the last one. That's human nature. Okay? So don't do this. You know why? Because, I mean, this is going to be you. You're going to be staring at the screen trying to see what the difference is between those lines. You know what? New lines are free. Use them. Okay? Don't do that. Don't put multiple statements on one line. All right, this is another one. Now, you can't do this yet. You don't know how to do stuff like this. But you will. Okay? All this says about you is that you're a jerk. Okay? You are not impressing anyone with how few lines you could write something in. For one thing, when you optimize your code, it's going to do better than you anyway, probably. Okay? Don't do this. What you're seeing here, what is the problem? The problem is that there are multiple side effects in here. So, for example, your Boolean expression here, that's the ternary operator, the Boolean expression here is only going to get executed if this Boolean is true. I'm sorry, the Boolean expression will determine whether this is done or this is done. So perhaps this decrement had to have been done all the time. That's going to be a bug. Think about what it would be if variable name, the same variable, was used in some of these, more than one of these blanks. Then you're thinking about index. Index plus equals, well, sometimes index might be decremented, sometimes it might be reassigned. Oh, just give up. I have no idea what's happening to index. Okay? So no one will be impressed if you write code like this. Okay? As I said, the optimizers will laugh at your puny attempts to be cool. All right? And you'll just piss people off. So here we are with assert. I've talked about it on the board, so I don't need to spend much time here. Any questions about assert? Assert is your friend. Get to know how to use it. Okay. Bug can't be here. I pasted this code from over there, and it works over there. But this version is different from that version. Oh, yeah. Okay. What's happening here is if you find yourself pasting code, a defensive programming technique is that pasted code really needs to be a function. So that if there's a bug, you'll find it in one place and you'll fix it in one place. There's nothing like realizing that you pasted code 10 times and you fixed a bug in 9 of them. Instead, that code should be a function so that the same code is executed every time. Okay? Code it in one place, test it in one place, fix it in one place. All right, here we go again with assumptions. This variable has to be one of these values. And in fact, if it's not one of those values, the code's going to crash. So you discover that the code crashes. But the variable has to be one of those values. Well, that's an assumption. Okay. So we laugh at your assumption. Inconceivable! You know the movie, right? Yeah. All right. So for a switch statement, in particular, case this, case that, case the other thing, always code the impossible case, the default. And if default should never happen, then put some type of warning in there to yourself, a printout, an assert, who knows. Okay? With if statements, always code the impossible else. So if, then, else, if, then, else, if, then, and you stop? What about that final else? If that should never happen, and it would be an error if it did, then code it. That's defensive programming. Okay? All right. My former colleague, Ben Liblet, that's in the fine print there. Before going back to school, getting a PhD, and joining the faculty at UW, he was an engineer at a company that will remain nameless, but they make most of the chips that go in your cell phones. And there was an argument. There was a code review. That's something that you'll start learning to do. Code review is where you stand up, also called a code stand-up. You stand up in front of your peers and you walk through your code so that the group mind will point out any bugs or improvements that can be made. You defend your code, and it's a good thing. Anyway, there's a code review, and they found that there is a loop, an inner loop that's executed billions and gazillions of times, and there's an assumption in it. And Mary says, we should really put a check in there for this case, just to be safe. And Bob says, don't be ridiculous. This code is executed billions of times. A, it's improbable that this will be a problem. And B, it's executed so frequently, we don't have time. It'll slow us down too much if we put that check in there. So, as is often the case, unfortunately, Bob shouted much louder than Mary, so everybody went with Bob. Okay? That's a dynamic which is not especially useful. But they went with Bob. 6 months later, the engineers receive an escalated bug report from tech support. And the cryptic message is, tell Bob Mary was right. You get what I'm saying? So after Bob turned his back, Mary put in the check and she was right. It took 6 months for the bug to show itself, but she was right. Okay? My code doesn't work. You're not checking the return value of that function. Let's say it's an int and you don't check the int. Let's say it's a bool and you don't check the bool. I don't know. You try to open a file, but you didn't check to see if it was actually open. Okay? Okay. So, when you're older and you've had me more and you know I'm kidding, I'll say, lean closer so I can slap you. Okay? You know I'm kidding. I hope you'll know I'm kidding. But this is really what it's all about. Okay? Mo, Larry, and Curly. Return values are there because they're supposed to be checked. Okay, so do that. Okay. I'm not going to explain this one. If I were talking to grad students, I would explain this. Okay. All right, now, Andy Warhol, famous artist, said this. Dying is the most embarrassing thing that can ever happen to you because somebody else has to take care of all your details. All right, this is, what I mean by this is that if your program has suffered a failure that is fatal, you should make an attempt to clean up after yourself rather than leaving files in an intermediate state, leaving the beam of radiation on permanently until the patient suffers a lethal dose of radiation. I don't know. You really should make an effort to clean up after yourself if you notice that you have found a fatal condition. Okay, so one last slide. I have others, but we don't need to look at them. Student says, every time I get here, I crash. Like, dude, or dudus. That's like the best thing that could happen, right? If you get to there every time and it crashes every time, that's like the easiest bug to find. So that's a good thing. Okay, so debugging is part of the process. Everybody writes bugs. When I write code later today, I'm going to write bugs. You write bugs. all of us write bugs. So debugging is not a punishment. It's part of the process. So take pride in your work, take pride in your craft, and embrace debugging. Get good at it. Make it your friend. It's like winter in Wisconsin. If you hate winter, winter is going to last forever. But if you make friends with winter, maybe you discover that putting on a coat helps. Maybe you discover that snowshoes are a lot of fun. If you make friends with winter, then winter's not a big deal. So make friends with debugging. Get good at debugging. Practice debugging. And it simply becomes part of the process. And in fact, I love debugging. It's like one of the most enjoyable parts of the process for me. I'm not saying I put bugs in on purpose, but when they happen, and they always do, I enjoy it. Okay? And then here's my mantra again, code like somebody's life depends on it, right? The older I get and the closer to a pacemaker I get, the more I'm interested in not dying because you had an off by one error, okay? All right, good. That's my talk on debugging. Who's got questions? This is online now. It's on the Facebook page for computer science, and everyone's joined, right? Who is on Facebook? Go ahead.
I think you're not a fan of debugging by print statements.
Debugging by print statements? Oh, on the contrary, it's a wonderful tool. So yes, I am a fan. And in fact, here's a few comments about, that's one of the slides I took out. Here's a few comments about debugging by printf or debugging by output. So one thing is, remember binary search. So if you have a crash and you don't know where, or if you have a bug and you don't know where, so put a comment out in, put a printout in the middle and just say, I got here. Okay, if the crash happens after that printout, then divide the second half in half. That's binary search. Okay? Yeah, give me a minute, but do remember to ask me your question or make your comment. I'm on a roll. I'm in my meditation. Okay? Now let me show you a couple of things that will help you in your printouts for debugging. There are a couple of symbols that are always defined for you, and you can take advantage of them. And another one that's good is underscore, underscore, all caps. So what do these do? This will get replaced with the name of the function you're in. So in one of your printouts, you could then say, I'm inside function name, and that's where this printout is coming from. And also, line number is the specific line. Oh, there's also okay. So I got to line 17 of file main.cpp. Okay. So one final word, and then I'll get to Cephas's question about using printout as a debugging tool. You will very quickly find a situation where you're printing out too much. So the very tool you were hoping would help you actually becomes a burden. So use the technique wisely. Okay, Cephas.
So for like checking if code works properly, could you just, instead of printing, just set a breakpoint? So if you presume that if it gets past this, then this is not the error code, and if it doesn't get past it, then you know this is where the issue is.
Yes, breakpoints can be very, very useful when you're running inside a debugger. Now, I'm using the term breakpoint, but when you're in the debugger, we're talking about the red ball. The red ball next to a line of code. that says there's a breakpoint on that line. So when you are running in debug mode, when you reach that line, the debugger will pause your program and you get a chance to look at stuff. Okay? Now, there's a problem leaving that code in. That's one point. But something else I want to say. What if the bug only happens on the 7,601st time through the loop?
I have no idea.
Right? So there's a few techniques that'll help you there. For one, you could say, actually put in code that says, if the loop counter is 7,601, force the debugger. There's always going to be some type of command, which is going to vary from language to language and operating system to operating system, that trips a breakpoint. An alternative to this, which I don't advise, and I'll give the reason, is to use a different kind of breakpoint. This one says, when you get here, stop. Okay? There's also conditional breakpoints. So you could do, you put a breakpoint into the debugger that says, if loop counter is 7,601, stop. The reason why this is not a great approach is because with every instruction executed, the debugger is going to check the condition. So it massively slows down your code. Okay? So if it's something like this, then do it that way. Okay? Other questions? What is the most important takeaway from this talk? Anybody? Go ahead.
Take things in small steps so you can treat it like a science.
Okay, so you said two things, and they're both great takeaways. I would say the most important is the scientific method. That was the latter half of what you said. But then in the beginning of what you said is take things in small steps. Write a little, test a little. Okay? So, scientific method, debugging shouldn't be by accident. If you use no rigor, no method, no methodology, you're going to spend the rest of your life debugging, hating your job. Okay? Because you're never going to go dancing. All right? There should be some dancing. There, I danced. That was actually among the best dancing I've ever done. Okay? So no more questions? Then I'll open it up to questions about your project, and if there are none of those, then we can end early. I'm sure you wouldn't mind. Any questions about the project? Go ahead, Sam.
Specific questions to our...
About your project? Don't you think that's being selfish?
Well, that's why I was asking before.
No, I'm kidding. I'm kidding, of course. So we can, if there are no other general questions, of course you can. By now you should know I'm pretty sarcastic. Okay. Yes. Yeah.
How would you access the line number in the text file? So like when you're looking for a word, how would you access the line number that word is on if it's not included in the map?
So the question was, how do you access the line number if it's not already included in the map? Okay, so the line number would be a variable that begins at 1, and each time you read in a line, increment it. Right? So the first time you've read a line, you're on line number 1. then make sure the loop, that line number counter is incremented, so the second time you're on 2. So when you find a word that hasn't been in the map before, you would be creating a node, which is a temporary thing. The node constructor sets frequency to 1, which is appropriate because it's the first time you've seen that word. Then it's your responsibility to do a pushback of the line number and then add it to the map. If this came up yesterday at the barbecue, which, by the way, thank you all who were there, thank you for coming, came up in the barbecue yesterday that the student's first time a word was found wasn't getting into the vector of line numbers. And the reason is that the line number, the first time, was being added to that vector after the node was added to the map. So remember that in place is going to make a copy of your node. If you try to use it after the in place, that node, that temporary node, you're not changing the node that's in the map, you're changing the local variable. And that will not lead to success. Okay? Yeah.
Do we need to have a quit option for them, or do we just put it in an infinite loop and let it go and then?
Well, it's not an infinite loop. You're using getLine to get the next word, right?
From the user.
Yes. So you're reading from the user, cin, you're using getLine.
So do you want it to be so that if they don't put something in, you just press enter? That's when it finishes.
Well, that would be a blank line. You're supposed to handle that. Okay. Instead, when does getLine return false?
It's just nothing.
It returns false. You want to tell us?
Control V if you quit out the program.
Right. So let's look at phase 1, using getLine to read the file. It's while getLine of the input file, comma line.
My question was just do you want us to ask the user to quit?
No, I promise I'm answering your question. Okay. So that loop at the first phase ends when the file has nothing left in it. That's called an end of file. Now, from the console where you're interactively using, that's phase 2 of the program, you're also in a loop asking for input. So if you enter an end of file, the loop will end. So from the console, depressing Control and the D at the same time is an end of file. So your loop will terminate with Control D. So I hope I answered your question. But no, don't put in a quit. That's not what you're supposed to do. Okay? Did it say that in the spec? Enter a quit to end? No, it doesn't. Therefore, don't do it. Okay? Any other questions? Have a supercalifragilisticexpialidocious break. Okay, have fun.